good guys know what the correct bingo number is, the good guys and the cargo, then everything's fine. As soon as the all okay signal quits coming, then we immediately detect that. I think we'll skip this. I'm going to run out of time here. So finally, if you'd like more information, we've got a book that's coming out shortly having to do with the idea of the weakest link in the chain of security. There's a lot of physical security books that offer insipid advice on how to do good security. Well, our book's going to offer insipid advice on how to have bad security. Because in the end, it's the mistakes you make that are more important for security than what you get right. That's because the bad guys don't attack randomly, they attack at the weakest link. And also, we are hosting the Journal of Physical Security. This is apparently the only peer-reviewed journal that's devoted to physical security, and it's free and online, and you can sign up to be notified when new issues come out. And if you'd like to download a whole bunch of reports, papers, and presentations on tamper detection and seals, including how to use existing seals better, you can find that at this website. Thank you very much.
Just a quick comment with that journal. We could really use paper submissions, especially from an audience like this. Typically, we get paper submissions from folks out in some company somewhere. Oh, we put in this burglar system and it seems to work. But folks from you, or submissions from you folks would be just great if you don't mind throwing some papers our direction.
I guess maybe we have time for a couple of quick questions. Yeah. Sure, it's not too different from a traditional seal, which has a serial number. And if the bad guys, let me repeat the question, sorry. Question was about, again, the insider threat and what if someone intercepts the information. Because as he points out correctly, for at least some of these seals, you need to send information to the receiving location that, about what they're supposed to see. That's not the case for all the seals, but it is for some of them. Basically, you have essentially the same kind of problem, a little bit different with a conventional seal. You want to protect the serial number, at least for a little while. Typically on a conventional seal, the serial number is on the outside and the bad guys can get a look at it. Hopefully with the anti-evidence seal, you've run the information through a completely different channel, one that you would use cryptography on. And, but once again, if you've got disloyal people, all bets are off. Technology doesn't save you from that. The other thing to point out is these seals aren't always just for cargo. Sometimes they're just for a vault. So you may stow stuff in a vault and want to come back later. So there's no, in that case, communication of information. You're just going to keep the reader, and you better secure it. But you're going to come back with that same reader and see if things change. In that case, you don't need to transmit any information. Any other questions? Yeah?
How do you deal with out-of-band auditing? In other words, people that are not privy to the knowledge around the seal but still need to validate it. Like, for instance, an inspector at a truck stop or TSA, which I do a lot of work with. They have to inspect in line as they're going through, but you don't want them, they're not sharing the secret information that you're showing.
Right. The question is when you have multiple players involved, and the example I'd give is customs often have to open trucks and take a look. They don't do much, you just kind of stare at it. But in that case, with a seal like this, you want to program the option to have multiple openings, possibly with only allowed windows. The nice thing about microprocessors is that's all trivial to do. So if you've got a situation where you suspect a seal would be open in a certain time or location, or even if you don't, you can program in a certain number of allowed openings, and you simply go to new anti-evidence. Now, is that as secure as having only one piece of anti-evidence and assuming only one door opening? No. But is it as secure opening the door a bunch of times with a bunch of different people? No. So those are the kind of trade-offs. If you want good security, only one guy should open the door. But as you point out, that's not always possible. Yeah, back there.
I presume with the magnetometer that it's important to reproduce where it's placed or mounted in relation to the sensor. And then I have a question about whether magnetometers are calibrated individually, or if you can measure a sensor with a different magnetometer the second, third time, et cetera.
Well, there's a question about magnetometers, about calibration sensitivity, and whether you have to position them accurately. And the answer is yes, you absolutely have to position them accurately. That turns out to be a problem solved in 1885. Kinematic mount, fabulous device. We can talk about it in more detail. It's basically 3 steel balls, like in ball bearings, that sits in a cone, a groove, and a flat. Not a precision device. You can just make one in your garage. Yet when it is set down, it will reproduce the position with extraordinary accuracy. And it's even to first order self-temperature compensating. Amazing device. So yes, you can re-register these images if you shoot them from slightly different positions, rotations, or angles. But if you use a good kinematic mount, the problem is essentially solved for you. The devices are so good, they're so good in absolute accuracy, that you really don't have to calibrate them nowadays. You're going to pay a little more for that kind of device. But in the end, we're mostly looking for changes, and typically fairly large changes, unless you really want to push the technique to incredible sensitivities.
But can you use a different magnetometer? Does it have to be the same one?
The question was whether you could use a different magnetometer. Answer is yes, there's some issues there. It's not totally trivial, but it's not nearly as difficult as you might think. Yeah, question?
One of our internet viewers has asked, is the U.S. doing competitively better or worse for using SEALs for nuclear weapons and WMDs than other countries, specifically the Soviet Union or other places?
The question is whether the United States is doing a better job with SEALs and tamper detection for nuclear safeguards compared to other countries. No, I think my personal view is it's a mess all across the world. We really don't have effective tamper detection, especially for international nuclear safeguards. A little bit better situation in most countries for domestic nuclear safeguards. But again, my view is it ought to be a lot better than it is. Any other questions? Yeah. Well, that's, again, some interesting semantics. Some people insist it's nuclear security and safeguards. Other people insist it's only nuclear safeguards. There's 2 kinds, and people confuse them all the time, including people who work in the field. There's domestic nuclear safeguards, where we want to stop the bad guys from wandering off with a nuclear device. And there's international nuclear safeguards, where we're trying to determine if a country is abiding by its promises vis-a-vis international treaties. Now, that latter is an extremely difficult problem. Number one, the adversary is a nation, very sophisticated technologically. But number 2, everything's all backwards. In a traditional security application, the good guys own the assets and the facilities where they're stored. The bad guys try to break in and get to them. With international treaty monitoring, the bad guys own the nuclear assets. They own the facilities. The inspectors are not going to be allowed in much of the time. The people being inspected have to have entire circuit diagrams, all the software information for the devices. They may actually have to provide them. So you're in a situation where the burglars are providing the burglar alarms, maintaining them, and not allowing the inspectors access to the whole operation. So it's completely backwards, an extraordinarily difficult kind of security problem, but one that really, I think, hasn't had the kind of creative approaches really needed. The domestic nuclear safeguards one is a lot better shape, but even that, I think, needs a lot more work. Anything else? If not, well, thank you very much.